Hello, Matthews, Gatos here. In this video, we're going to cover solving quadratics by factoring. But before we do that, let's review what we did in 4.1. So in this question here, we are given a quadratic equation with one parameter missing, the y-intercept, and we know the solution. So we want to work backwards to find that value of p. So remember in 4.1, we learned that a solution to a quadratic satisfies the equation. And what I mean by that is if I were to take my solution and substitute it in place of my x values, I would, after doing that, create an equation where the left side equals to the right side. So I'm going to do that knowing it's the solution to solve for p. So I'm going to have 2 times negative a half squared. It's really important you put them in brackets, especially when you have a negative value, plus p equals 0. So negative a half squared means negative a half times negative a half, which is a quarter. And then 15 times negative a half, I'm going to change that, would be minus 15 over 2 plus p equals 0. So 2 times a quarter is 2 quarters. And just to make it a little easier, I'm going to put 2 quarters in lowest terms, which is really a half, because now we have a common denominator. So a half take away 15 over 2 is negative 14 over 2 plus p equals 0. Now negative 14 over 2 is really negative 7. So I will add 7 to both sides, and I get that p has a value of 7. So that would be the answer to this question. So a little bit of a twist on solution to a quadratic. Let's look at this one here. So we have a quadratic f of x, and it has 2 real zeros. One of the zeros is x equal to c. So we have 5 statements made. 2 of them are incorrect. We have to find out which ones are incorrect. So x equals to c is the solution. Because it's the 0, it's also the solution and also a root. So right off the bat, we have 2 that are true. So remember, when I have a solution, it means zeros, roots, x-intercepts. Oh, that brings me down to number 4. C0 is the x-intercept of the graph. So there are my 3 true statements. Let's look why the other ones are false. So if x equal to c is a 0, remember the question I gave you when I gave you the roots of an equation and asked you to determine the factors. Well, if this is the root, we set it equal to 0 by subtracting c from both sides to find the factor. So the factor is not x plus c, it's actually x minus c. So that's why this one is false. So even though we only have 2 left, you should always check to make sure they're correct. Now it says C0 is the vertex of the graph. Now if I only had 1 0, so if I only had 1 0 across the x-axis and we don't know what the value of c is, let's say that this value of c was right there. If I had just one x-intercept, that would be a perfect square trinomial. And in that case, the 0 would also be the vertex. But that's not the case here. We're told that we have 2 real roots, which means I cross at some point, doesn't really matter where, let's say here. So I have 2 solutions. One of them is x equal to c, and you can see that is not the vertex. So that's why this one is false as well. Okay, so let's look at section 4.2. So we're going to take that factoring that you guys reviewed and take it one step further to find the solution. So to solve by factoring, what you're going to do is first of all set the equation equal to 0. Once it's set to 0, you're going to factor the equation and set each factor to 0 to solve. Now, why are we setting each factor to 0? Well, it has to do with the 0 principle. So the 0 principle says if I have 2 numbers that multiply to equal 0, then A could equal 0, or B could equal 0, or both of them could be 0. So that's why when we factor, which is like A times B, and we set it to 0, we set each factor equal to 0 to solve. And once we've done that, we state our answer, and then we check each answer in the original equation. And we're going to do that through the graphing calculator. So solving quadratic equations by factoring is the same thing as finding x-intercepts algebraically, because remember, solutions, zeros, roots, x-intercepts, they all mean the same thing. So since x-intercepts are where we cross the x-axis, the y-coordinate is 0. So that's why we set the equation equal to 0. Now, remember when you're solving this by factoring, you always have to look for the greatest common factor first. So look for the greatest common factor first and then factor whether it's a perfect square trinomial, difference of squares, or just a trinomial in general. So let's try some questions. So in this question here, I want to solve x squared minus 4x minus 12 by factoring. So first thing that I'm going to do is look for my multiplying and adding numbers. So remember, because it's x squared, there's really a 1 in front. So I'm looking for two numbers that multiply to 1 times negative 12, which is negative 12. And add to the middle, which is negative 4. So if you know those numbers already by yourself, you're good to go. Otherwise, you can go to your graphing calculator and look in the table. So since I'm looking for factor pairs of negative 12, I enter negative 12 divided by x into my calculator. These are all the factor pairs of negative 12. I'm only looking for integer factor pairs. So you can see here I've identified that positive 2 and negative 6 are the ones that work. So let's write that in here, and then we're going to just check it. So positive 2 and negative 6. So 2 times negative 6 is negative 12, yes. And 2 plus negative 6 is negative 4. So I know I found the correct factors. So to factor, I use my grid method. So I put my first number here, which is x squared. I put my last number here, which is negative 12. And then I take my two middle terms and put them in any order. I usually just go with the first one here, and then the second one over here. And then, just like completing the square, I factor out by GCF. So in this first column here, I have a greatest common factor of x. In this second column here, I have a greatest common factor of 2. In the first row here, I have a GCF of x. And in this row here, I have a GCF of 6. But remember, because it's negative, we take the negative out. So it's going to be x minus 6. And that does not appear to be working for me, so I'm just going to write it out. Okay, so when I do this, x minus 6, I always do a quick check. X times x is x squared, 2 times x is 2x, x times negative 6, negative 6x, 2 times negative 6, negative 12, just to make sure that I'm right. Okay, so I now know that it factors as x plus 2, x minus 6. But we want to take it that one step further and solve. So what I'm going to do is set each factor equal to 0. So I'll write it out so that x plus 2 equals 0, or x minus 6 equals 0. So over here, I will subtract 2 from both sides. So x equals negative 2, or add 6 to both sides, x equals 6. So I think that that is my solution. But anytime I'm solving an equation, I always do the check. And the check happens in the table. So let's look. I would put my original equation into y1. And you can just go straight into the table, or you can actually just start the table at your solution so that you can see what your solution is. So the first thing that I thought it was 6. So I start my table at 6. Table start is second window. And you can see in the table that 6 does in fact make it 0. So I know x equal to 6 is a solution. Then the other solution I had was negative 2. So I start my table at negative 2, and I see that it also makes the equation equal to 0. So I know that x equal to negative 2 is a solution. So every question that you do, I want you to check. Now, whether that check is looking at your answer in the back of the book or my detailed solutions, make sure you check. On a quiz, you would check, of course, with the graphing calculator. Okay, let's try another one. So I have negative 2x squared plus 12x plus 16. So my very first tip for you is I want you to isolate the variables so x squared has a positive leading coefficient, and then always look for a GCF. So first thing I'm going to do, because I have my 2x squared is negative, I'm going to add 2x squared and subtract 12x from both sides. So add 2x squared and subtract 12x. So then it's all gone, and I have 0 equals 2x squared minus 12x plus 16. Okay, so now that I've made my leading coefficient equal to a positive number, I'm just going to look to see if I have a GCF. So since all the numbers are even, I know I have a greatest common factor of 2. So let's factor out a greatest common factor of 2. So 2x squared divided by 2 is x squared. Negative 12x divided by 2 is negative 6x. 16 divided by 2 is positive 8. So this is the quadratic that I'm going to factor, and you'll notice down here I kept my 2 outside. Don't forget about the 2. Okay, so now I'm going to look to factor it. I'm going to look for 2 numbers that multiply and 2 numbers that add. So looking for the 2 numbers that multiply, remember there's really an imaginary 1 in front of here, in front of that x squared. There's an imaginary 1. Let's try this again. There we are. So I'm going to do 1 times 8. That's what I'm looking for. 1 times 8 is 8. So I'm looking for 2 numbers that multiply to positive 8 and add to my middle term of negative 6. Okay, so again, if you don't need the calculator to find these factor pairs, you don't need it. It's just here in case you do. So looking at all the factor pairs of 8, I do in y1, 8 divided by x. And I'm looking for factor pairs that multiply to a positive, add to a negative. Well, the only way that's possible is if both numbers are negative. So I went backwards in my table to look at my negative numbers. So I know that negative 4 times negative 2 is positive 8, and negative 4 plus negative 2 is negative 6. So over into my grid here, my first number goes here. So this will be where my x squared is. My last number, positive 8, goes here. And then I just take my factors. So negative 4x and negative 2x. And then it's just a matter of factoring by GCF. So along here I have a greatest common factor of x. Along here, greatest common factor of 4, but it's negative. So I should have x minus 4. Over here, GCF of x, and over here, GCF of 2, but take that negative out, so it'll be x minus 2. And again, you can do a quick check to make sure that that is right. So when I factor it, it's going to be in either order, x minus 4, x minus 2. So to solve this, let's set each factor to 0. Now the 2 only has to go with one of the factors, not with both. So I always just pair it with whatever my first factor is. And then my other factor is x minus 2 equals 0. So I'm just going to solve these two. So here the first thing I'm going to do is divide both sides by 2. So x minus 4 equals 0. Then I'm going to add 4 to both sides, and I get x equals 4. That's my first solution. Or on this side here, I will add 2 to both sides and get x equals 2. So those would be my 2 possible solutions to that quadratic. Okay, what I would recommend is you guys pause the video and try this one on your own, and then come back and watch the solution. So the very first thing that I want you to remember is to set your equation equal to 0 first. You have to set it equal to 0. So I'm going to subtract 21 from both sides. So I will have 6x squared minus 5x minus 21. So we're going to again look for GCF. There is no GCF between these numbers here because I know 5 is a prime number. Okay, but again, you can check it in the calculator using that tip I showed you before. So I want to find 2 numbers that multiply to, let's try that again. So 2 numbers that multiply 3 times a charm, right? There we go. So I want to find 2 numbers that multiply to 6 times negative 21, which is negative 126, and add to my middle term of negative 5. So again, you can do these on your own or go into the calculator and check. So in the calculator, I'm looking for factor pairs of negative 126. So looking here, I can see I've already circled it, that I have positive 9 and negative 14. So let's write those out. Positive 9 and negative 14. Just go through a quick check. 9 times negative 14 is negative 126, and 9 plus negative 14, negative 5. So I know I've done that correctly. Okay, so let's set it up in our grid. So first thing first, our first number goes here. So this would be 6x squared. Our last number, negative 21, goes here. And then our factors in any order. Doesn't matter which order that you put them in. So 9x and negative 14x. So GCF along here would be 3 and x. GCF along here would be 7, but because it's a negative, take that negative out. So 3x minus 7. Over here, I have a GCF of 2x, and over here, I have a GCF of 3. Take out the positive, and it's 2x plus 3. So I've got 3x minus 7 and 2x plus 3. And now I'm ready to solve. So I'm going to set each factor equal to 0. So 3x minus 7 equals 0, or 2x plus 3 equals 0. So here I'm going to add 7 to both sides. 3x equals to 7, and then I will divide both sides by 3, and I will get x equals to 7/3. Let me make this just a little bit bigger for you to see and scroll down. There we go, that's better. Okay, this one here, I'm going to subtract 3 from both sides to get 2x equals negative 3, and then divide both sides by 2 to get x equals negative 3/2. And that is exactly how I want you to leave your solutions. I don't want decimals. So my tip to you is oh my goodness, can't talk. When a quadratic can be factored, that means your solutions should be stated as exact values. So I wouldn't want to see these as decimals. Only time decimals are okay when something can be factored is in a word problem. But when I'm talking about just solving quadratics, please leave them as exact values. Okay, so I want to look at this one here. This is called complex factoring. So I know, looking at this question, the temptation is to start expanding. So to write it out, I know that a lot of students would jump into this and just start going like this. X plus 2 times x plus 2, and then distribute the negative 7 in, and then away you go. Now, that way of solving is completely valid, but I want to show you another way of looking at it that's going to save you a lot of time. Okay, this looks like it already is a trinomial because it's 6 something squared minus 7 times that same something equals to 3. So if I were to set this equal to 0 first, I would have 6 times x plus 2 squared minus 7 times x plus 2 minus 3 equals 0. Because remember, we always set it to 0 first. Okay? So that would look like a good way of solving it, by expanding it. But we can actually solve this by substitution. And that's what I want to show you. Okay? So we're going to factor it by substitution. So instead of using x plus 2 squared, I'm going to use d to represent x plus 2. Because this looks like a trinomial. See? 6d squared minus 7 times d minus 3. So this is a lot easier to factor than what I started with. So that's exactly what I'm going to do. I'm going to factor 6d squared minus 7d minus 3. So let's look at setting it up. So setting it up again, I would look for two numbers that multiply to 6 times negative 3, which is negative 18. Oh, not add. Okay, and add to my middle term of negative 7. So again, if you can do these yourself, great. If not, if you need a little help, the graphing calculator is a good option. So looking on my graphing calculator, I'm looking for factor pairs of negative 18. So these are all the factor pairs. I'm just interested in the integer pair that adds to negative 7, which you can see I have circled as positive 2 and negative 9. So positive 2 and negative 9. Do a quick check. 2 times negative 9 is negative 18. 2 plus negative 9, negative 7. So now we're good to go and factor. So factoring here, this is my simpler polynomial that I'm factoring. I'm going to put my 6d squared first, my negative 3 second, and then my factors of positive 2 and negative 9 go right here. So factor by GCF. So along here the GCF is 3d. Along here there is no GCF, but everything has 1 as a common factor. Along here I have a greatest common factor of 2d. Along here it's 3, but because the leading coefficient is negative, take out that negative as well. Okay, so now I know how it factors. So when we're factoring this, remember, we actually didn't start with d. So while it looks like the factor would be 3d plus 1 times 2d minus 3, we actually started with x plus 2's, or x's. So if d equals x plus 2, I know 3d multiplying by 3 would be 3x plus 6. So let's replace that over here. So 3x plus 6, that's what 3d is, but I have to add on my 1. And 2d. So if d is x plus 2, 2d would be double that, which is 2x plus 4. So 2x plus 4, that's what 2d is, but don't forget to subtract 3. So going down here to finish it off, for the factoring, I would have 3x, 6 plus 1 is 7. And over here I would have 2x, 4 minus 3 is 1. So all we have to do is set each factor equal to 0 and solve. So 3x plus 7 can equal 0, or 2x plus 1 can equal 0. So here subtract 7 from both sides first. So we're really doing reverse order of operations. Add and subtract first, and then divide second. So one solution is x equal to negative 7/3. Over here, subtract 1 from both sides, divide both sides by 2, and x equals negative 1/2. So those are the two solutions to that original quadratic. Again, you could expand group-like terms and then factor. I just wanted to show you a little shortcut you can be on the lookout for. Okay, so over here I want to look at how do we create a quadratic that has roots of 3/2 and negative 2. So what that really means is I'm starting with my solution and I'm working backwards to find the quadratic. So we're going to do exactly that. So we're going to start with our x-intercept. So I'll do this one at a time. So I'm going to start with negative 2 first. Okay, so if that is my solution, let me actually write it like this. X equal to negative 2. That's my x-intercept. My factor would be, set it equal to 0, add 2 to both sides. So my factor would be x plus 2 equals 0. Now I'm going to do that for the same one on the other side. Let me just move this down here. Okay, so I have x equal to 3/4. Now, when I'm creating a quadratic, I do not want any fractions at all. I believe that's my next tip. Yes. So factors can't have fractions. So see how it's x equal to 3/2? I'm not going to subtract 3/2 from both sides. I'm actually going to multiply both sides of the equation by 4. So if I multiply x by 4, I get 4x. And if I multiply 3/4 by 4, 4 divided by 4 is gone, I get 3. And then I will subtract 3 from both sides. 3 take away 3 is 0. 4x minus 3 equals 0. So I've done my x-intercepts to factors. Now what I have to do is multiply. Multiply the factors together. So see, we're just going backwards in this process. And then I'm going to apply the distributive property to figure out what my quadratic is. So let me just give myself a bit more room there. So I have x times 4x, x times negative 3, 2 times x, and 2 times negative 3. So my quadratic, once I've grouped my like terms in the middle here, 8x take away 3x, 5x. There is my quadratic. So this quadratic has solutions of -2 and 3/4. Please remember this tip here. Anytime you're factoring, you cannot have fractions. So you saw how I got rid of those fractions. So I just want to end with a word problem here. In this question here, we have the length of a rectangle. The length of a rectangle equals twice its width. So if this is the width, this is the length, which is twice the width. And I'm told that the area is 32. Okay, so I know area is length times width. So 32 equals 2w times w. And that would just be 2w squared. So I'm going to solve this by setting it equal to 0, 2w squared minus 32, and then I'm going to factor. So this is a great opportunity to review difference of squares and greatest common factor. So see how both numbers are even? I'm going to factor out a 2 first. So 2w squared divided by 2 is w squared. 32 divided by 2 is 16. And w squared minus 16, that is a difference of squares. It's a binomial where each of the terms are perfect squares and they're subtracted. So the square root of w squared is w. The square root of 16 is 4. I add one set and subtract the other. So to solve quadratics, we always set each factor to 0. So keep the 2 with the first factor. So I have 2 times w plus 4 equals 0, or w minus 4 equals 0. So here, let's first of all divide both sides by 2. So I divide this side and this side by 2. So I'm left with w plus 4 equals 0 divided by 2 is 0. And then I will subtract 4 from both sides, and w equals -4. Now, w is a width, and you can't have negative width. So while this is a solution to the quadratic, it's not a solution to our word problem. So w cannot equal to -4. So what that means is this is an extraneous root, meaning it's a solution to the quadratic, but not to our original question, because measurement can't be negative. Okay, so let's go over here, add 4 to both sides, and w equals to 4. So w is my width, so I can come back up here, and I'm just going to substitute in w for 4. So that means that the width of this is 4 centimeters, and the length is 2 times width, double the width, which would be 8 centimeters. So the dimensions are 4 centimeters by 8 centimeters, and they also want the perimeter. So if this is 4 and this is 4, this is 8, this is also 8. The perimeter is going to be 8 plus 4 is 12, plus 8 is 20, plus 4 is 24 centimeters. I feel like I did that. Yes, I did that right. Okay, I was doubting myself for a minute. Okay, so that's how you can use quadratics and factoring to solve word problems. But again, remember, solving quadratics are all about finding the roots. And it's really important to know your roots. You guys can go on and do questions attached to the notes. Detailed solutions are on D2L, and then move on to the textbook. So I hope this video helped, and I look forward to seeing you for the next one.